In this video, we will discuss ionization of weak acid. We are going to discuss the following points. First, we will discuss how to find approximate solution of a weak acid solution. So let us say first is we have to find H plus concentration, and this is approximate method. Then we will discuss how we can calculate H plus by exact method. That is, next we will discuss exact method. Now further we will discuss how the approximate method is a special case of exact method. So this means exact method we can derive approximate. In the last, we will also discuss error. So we will discuss how to find error. If possible, we will also discuss one problem related to all these ideas. So let us discuss. I take HF. This is a weak acid. HF is a weak acid. If you have some idea of acid base, HCl, HBr, HI, all these three acids are basically a strong acid. But HF is a weak acid. Ka value, ionization constant value for HF is 7 into 10 to the power minus 4. So this is the ionization constant value. If you write reaction HF dissociates in aqueous solution, it will give H plus plus F minus, and the K value is given to you for this equilibrium. So this is the ionization of HF. K is given to you. For this reaction, that is the ionization of HF, delta H degree, that is the heat change at 25 degrees centigrade, this value is minus 3 kilocalorie per mole. So this means since delta H is negative, that is the reaction is exothermic, so delta H degree basically favor this ionization. So this favors this ionization. So I can say delta H degree is exothermic and favors ionization. So process of ionization is favored by delta H degree. But now for the same reaction, if I look for the value of delta S degree, that is entropy change at 25 degrees centigrade, this value is minus 24.5 calorie per Kelvin per mole. Now see, this delta S degree is negative. If you remember second law of thermodynamics, we said if delta S degree is greater than 0, process is spontaneous. But now here delta S is positive, not positive, this is negative. This means by the entropy factor, this process, the ionization process is disfavored. So I can say entropy factor disfavors the process of ionization. And why this is so? So this means why entropy change for this process is negative. Why entropy change for this process is negative? So my question is, why entropy change for HF dissociate gives you H plus plus F minus? Why entropy change is negative? This is because solvent molecule, that is water molecule, after the ionization becomes ordered. So you see, let us say I have solution. So initially my solution water molecules are basically disordered. So water molecules are disordered. So they initially before ionization water molecules are disordered. So water molecules are. But now after ionization what happens? You see here, this F minus has a negative charge. This basically gets solvated by the water molecule. So water molecule has a dipole moment. This has a positive end, this has a negative end. So F minus gets surrounded by water molecule. And now this water molecules gets ordered. That is due to hydration of F minus, water molecules gets ordered. So now I can say water molecules are ordered. And that's why the delta S is in this case negative. This side we have more entropy, this side we have less entropy. So I can say due to solvation of F minus fluoride ion, entropy change, entropy decreases. I can say entropy decreases. Now come to the original point, that is the dissociation of HF. So if I say dissociation of HF, this will give you H plus plus F minus. Equilibrium constant for this reaction is K. Let us say initially I have C mole of HF in 1 liter solution, that is the concentration of HF is C. Initially I don't have any H plus, I don't have any F minus. At equilibrium, let us say X mole of per liter HF dissociates, so I will have C minus X, HF left X, and here I will have X, because 1 mole of HF dissociate, it will give you 1 mole of H plus, and it will also give you 1 mole of F minus. Now we can write equilibrium expression, that is X. So equilibrium expression is H plus F minus, and this divided by concentration of HF, this is equals to Ka. Now if I plug this value, H plus is X, so X into X, that is X square divided by C minus X, and this is equals to Ka. Are you getting? Same thing we can write here. So I have X square divided by C minus X, this is equals to K. So now I have this expression. Only thing is I have to solve for X. So first we will discuss approximate method by which we can solve for X. So first task is, that is the approximate method, approximation. So what is the approximation I am going to make? This X is very less compared to C. This is logical. Let us say I have C, that is 0.1 m. So I have a concentration of HF is 0.1 m, and I know in case of weak acid only 5% to 10% dissociations happens, even less than 5%. So if I have 0.1 and then 5% of 0.1 will be 0.005, then I can subtract 0.1 minus 0.005, that is same as 0.1, approximately same as 0.1. So what I am saying, I can say C minus X is approximately equals to C, and this is because ionization is very low. Ionization is a small, or I can say less than 5%. That is a case of weak acid. So you have to check this approximation in the end also. So let us say apply this approximation. So I have x square, and now c minus x can be written as c. This is equals to Ka. So from here I can find x is equals to x square is equals to c into Ka. From here we can write x is equals to under root c into Ka, and x is nothing but concentration of H plus. You see here. So now I have H plus concentration, that is equals to Cka, under root Cka. Okay, let us do one calculation. If I have H, this is C is equals to 0.1 m, that is the concentration of HF, and Ka value we have already given. Ka is 7 into 10 to the power minus 4, and we want to calculate what is the H plus value, approximate. So H plus is given by this formula, that is the C under root Ka under root C Ka. So H plus we will have under root C, C is 0.1, and K is 7 into 10 to the power minus 4. So we can calculate this value. Let us use the calculator. So I have a square root of 0.1 into, so this is 0.1 into 7 into 10 raised to the power minus 4. This value comes out to be 0.0084. So this is around 0.0084. So this is the approximate solution. I have H plus concentration in this case. This is equals to 0.0084. Now we can also do the same thing by exact method. So we discussed something how to calculate concentration of H plus by approximate method. Now we'll do the same thing by exact method. Now this is easy to discuss exact method. I have a binomial expression here, that is this expression. So this expression I can use this expression as a binomial expression, and a quadratic equation, and we can solve. So I have x squared divided by c minus x. This is equals to Ka. So from here I can write x square is nothing but Ka times c minus x, and from here I can also write x square is equals to Kac minus Ka into x. If I take all this side, so I will have x square plus Ka into x, and this is minus Ka into c. This is equals to 0. So this is a quadratic equation. So we can solve for x minus b, that is minus Ka, plus minus, we will have two root. Let us neglect the negative root because we cannot have a negative solution for H plus. This is a physical quantity, so I have to consider only the plus sign. Minus b plus root over b square minus 4ac. So b is this, b square minus 4ac. So this minus minus becomes plus 4Ka into c, that is 4ac, and this divided by 2a. A is 1 here, you can see clearly. So this is the solution, that is the H plus concentration is minus Ka plus under root of Ka square plus 4Kac divided by 2. One can solve the same problem, that is the concentration of initial Ha is 0.1 and K is this. If you plug all these value Ka, Ka and C, you can calculate the more exact value for H plus concentration. I am interested in here something different, and what is this? I can do this. This is a basically exact solution. So let us call this type of solution is solution number 1. And this type of solution, let us call this is a solution number 2, that is the exact method. Now we can further do some approximation to make solution better. First what we can do is, now you see Ka value is 7 into 10 to the power minus 4. What is the value of Ka square then? So Ka square is 7 into 7 49 and 10 to the power minus 8. What is the value of 4 into Ka into C? So I can also calculate value of 4 KAC. 4 into 7 into 10 to the power minus 4, and C is only 0.1, so I will have 7 into 4 28 into 10 to the power minus 5. So from these two calculation, one thing is clear, that is basically Ka square, this number is much smaller than 4 KAC, because this is 10 to the power minus 8 and this is 10 to the power minus 5. So I can say Ka square is much smaller than 4 times KAC. Are you getting? This means I can ignore Ka square compared to 4 KAC. So if I do that, let us see what happens. So what I am doing, ignoring Ka square. So let us say ignoring Ka square with respect to 4 KAC. So what we will have? We will have, you see this solution, I will have minus Ka plus, and this is nothing but, since I have ignored K square, so I will have 4 KAC, and in denominator I will have 2 also. So this divided by 2. Now you see, so I will have minus Ka by 2, and this 2 outside the root cancels out, so I will have under root Ka into C, because this 2 and this 2 cancels out, so I will have concentration of H plus, this is equals to under root Ka into C plus, and this is basically minus here, so I will have minus Ka by 2. So this solution, you see, I am getting this solution from exact solution. Let us call this as a solution number 3. This is not exact because I have made some approximation in this case, but even better result. So this is a good solution but not exact. Good solution but not exact. Even I can do some more approximation. So let us do some more approximation. So what I am going to do, let us calculate this value, check this value under root Ka times C. What will happen this value? Ka is 7 into 10 to the power minus 4 and C is 0.1. So this is coming out to 7 into 10 to the power minus 5, and find the root of this value. So how much it will come? So let us check this value, 7 into 10 to the power minus 5. So let us find a square root of 7 into 10 raised to the power minus 5. This value comes out to be 0.0084. So this is here 0.0084. And now let us say value Ka by 2. What is the value of Ka by 2? K is 7 into 10 to the power minus 4, and this divided by 2, that is 3.5 into 10 to the power minus 4. You see, now I can see this value. This value can also be written as 8.4 into 10 to the power minus 3. So this value can also be written as 8.4 into 10 to the power minus 3. I think you can understand this one. Now you see this value 8.4, 10 to the power minus 3. Here I have 10 to the power minus 4. So we can do some more approximation. What is the approximation? That is, this value Ka by 2 is a smaller than under root k into c. So what I am going to do, I can say ka by 2 is a smaller than under root ka into c. Are you getting or not? Basically this is not much smaller, but of course this is just smaller. So what we can do is we can ignore ka by 2 with respect to under root kac. So what we can do, ignoring under root ka by 2 with respect to under root ka into c. So if I do this, what will happen? So if I ignore this Ka by 2, so H plus concentration, what will be the H plus concentration? So I have H plus, this is equals to under root C into Ka minus Ka by 2. This value see here, minus Ka by 2. Now we can ignore this Ka by 2. If I ignore this value, so I will have H plus is nothing but under root C Ka, and it's surprising result because this is same as the first solution. So what is the first solution? So we have done this approximate method and we found this solution. So you see we got the same solution here, that is c under root k. So what we are doing, basically we are making more and more approximation in exact solution to get the approximate solution. Are you getting or not? Now we will discuss error in approximate method. So what is the error in approximate method? That is the method number 1. You see, if somebody asks which is the most appropriate method, then exact method is the most appropriate method. Are you getting or not? This method is the most appropriate. But now this is the approximation method, takes less amount of time, and this method I want to find what is the error in this case. So what I am doing in this method, in solving this, I am writing c minus x is equals to c. This is the error. So what I am doing, I am writing c minus x is equals to c. So we are making basically error of x. Are you getting or not? So what is the error? Error in this case, error is equals to x. If I ask what is the true value, so this c minus x is the true value and c is the approximate value. So let me write true value is c minus x. What is the approximate value? Approximate value is c. Are you getting? What is the fraction error or percentage error? So we can also find percentage error. This is equals to x divided by true value. True value is c minus x. But this percentage error, since this we can also write, since we does not know the x, because x is, we are calculating the x is also have error, so c minus x can further be written as c. So what we can write, this is percentage error can also be written as x by c minus x, and c minus x can be written as c. One important point here we have, this error is not exact. So even in calculating percentage error we are doing error, because this c minus x, we are making an approximation c minus x is equals to c. I have to multiply by 100 also to calculate the percentage error. Let us say my method says 5% error is allowed. So limit, what is the limit we have? Limit is, in this kind of calculation, for weak acid calculation 5%, let us say error is allowed. So I have 5% error allowed. So we can write this error, that is x by c into 100 should be less than 5%. Are you getting or not? And what is x? X is nothing but concentration of H plus. And what is the concentration of H plus in the method number 1? That is under root CKA. So you see what is the under root H plus CKA under root CKA. So now I can plug this value h plus here I have, that is under root CKA. So if I plug this value here, x is nothing but h plus under root CKA, and this divided by c into 100. So let us take 100 this side, 5 by 100. So I can have this c and this c, so I can write, if you do some algebra, this is less than 1 by 20. If I square both sides, so I will have Ka by c is less than 1 by 400. Are you getting or not? So this means if I have Ka by c which is less than 1 by 400, my approximation is allowed. I can also write, let us say, this side and this side. I can also write the same way, that is 400 should be greater than less than c by Ka. So if c by Ka is greater than 400, that is c by Ka is greater than 400, approximation is allowed. Are you getting or not? So in this case, approximation is allowed. Let us do some work. If I have the same acid HF, my C is 1m and Ka is given to you 7 into 10 to the power minus 4. Can I do approximation in this case? A rough idea. I need a rough idea. So you can check yourself what is the value of C by Ka. C is 1. So 1 divided by 10 to the power minus 4. So this is 10 to the power 4 divided by 7. Of course, this number is going to be greater than 400. So approximation is allowed. Approximation is allowed. So in this case, approximation is allowed. Okay. Now let us say I have C is 0.1 m and K value same, 7 into 10 to the power minus 4, and check whether approximation is allowed or not. So I have 0.1 and this value is 7 into 10 to the power minus 4. So what I will have, this is 10 to the power 3 divided by 7. So 10 to the power 3 divided by 7, I can use my calculator. That is 10 to the power 3 is 1000 and this divided by 7. So this is 142. So this value is 142. And this value I can also calculate. Let me check there. So 140 and this divided by 7. This is 1428. 1428. So you see, in this case approximation is okay because this number is greater than 400, but in this case approximation is not okay because this value is less than 400. So I can say in this case we cannot do approximation. Approximation is not allowed. Approximation is not allowed. From where it is clear, if my concentration is high, approximation is allowed. If concentration is low, approximation is not allowed. So I can say for weak acid, if solution becomes dilute, we cannot use approximation. So we can write here, for weak acid, if solution is dilute, if solution is dilute, solution is dilute, approximation is not valid. Are you getting? So once you make the solution more and more dilute, this becomes approximation becomes less and less valid. Now let us discuss one problem related to the idea whatever we have discussed. So let us say I have acetic acid CH3COOH and K value for this is given to you, that is 1.76 into 10 to the power minus 5, and concentration of acetic acid, let us say 0.02. So initial concentration of acetic acid, this value is given to 0.02 m. What is your task is to calculate the H plus concentration by different methods. First use the approximate method. You can also find by exact method. Do some error analysis, this kind of thing. So let us say I have acetic acid and this will dissociate and this will give you CH3COO minus H plus, and this K value is given to you. I have C00. This is C minus X, this is X, this is X. Now if I do the approximate, I will have X is equals to under root Ka times C. This we have already discussed. So this is your approximate solution. That is K is 1.76 into 10 to the power minus 5 and C is 0.02. So we can calculate this value. So use calculator. So square root of 1.76 into 10 raised to the power minus 5 into 0.02. This value comes out to be 0.006. Or if we can take more figures, so let us say 5 digit. So this is 0.00, that is 5 point. So I have here that is 5.9, 1, 2, 3, 4. So 5.9 into 10 to the power minus 4. Are you getting? So this value is 5.9 into 10 to the power minus 4. Let us check whether approximation is allowed or not. One way is I can check C by K value. So we said C by Ka is greater than 400, approximation is allowed. So let us check what is the Ca, that is Ca is 0.02 and this divided by Ka, that is 1.76 into 10 to the power minus 5. So you can clearly see this is 2 into 10 to the power 3 divided by 1.76. So even this becomes 2 and this is also 2, let us say. So this is 1000. So this is, of course, this number is greater than 400. So I can say approximation in this case is allowed. Now we can also find what is the percentage error in this case. You see, we can find percentage error. So what is the percentage error? Because we does not know the true value, we cannot calculate percentage error, but we can calculate approximate percentage error, that is X by C into 100. So what is the value of X? X is 5.9 into 10 to the power minus 4. And this C is 0.02 into 100. So let us calculate this value. So I will have 5.9 into 10 raised to the power minus 4 into 100, and this all divided by 0.02. So this comes about 2.95%. So this is around 2.9. So we are making a error of 2.95%, that is very less error. lesser than 5%. That's why approximation is okay. Now let us discuss exact solution. So we can have exact solution, and there is the method of quadratic equation. So x is minus b, you see, minus. So if you remember, we can write this solution. You see, we have written here. So this value, that is the true value, I have this one. We have already written this one. That is the minus k by minus k plus 4. So this value, we can calculate h plus here. So x is equals to h plus and minus ka 1.76 into 10 to the power minus 5 plus 4 times Ka, that is 1.76 into 10 to the power minus 5, and Ca is 0.02, and this all divided by 2. So this is slightly difficult to calculate. You can check this one. So let us say use calculator. So I have, so we can write here. So we have a square root of 4 into 1.76 into 10 raised to the power minus 5 into 0.02, this plus also minus, we have this value is minus, so this value is minus 1.76 into 10 raised to the power minus 5, and this all divided by 2. So this all divided by 2. So this value 0.0058. So this value basically I can write 5.8 into 10 to the power minus 4. So this is 5.8 into 10 to the power minus 4. You see, what is the value from approximate method? Approximate method, this is 5.9 into 10 to the power minus 4. This value is coming out to be 5.8 into 10 to the power minus 4. I can also find one more exact solution that basically that is between exact and approximate. So I also have a solution that is better than approximate but less accurate than exact. But less accurate than exact. And what is this solution? If you remember, so if you remember, this solution is, we have already said, this is this solution, h plus is under root KAC minus KA by 2. So this solution we have done, if you remember. Now we can find, did you remember or not? So let me show you, this solution is here. So this one, I said if you ignore this value KAS square with respect to 4KC, if you ignore KAS square, this one, if you ignore KAS square with respect to 4KC, you will get this solution. Are you getting? So now the same thing, I have under root Ka, K is 1.76 into 10 to the power minus 5, and Ca is 0.02 minus K is 1.76 into 10 to the power minus 5, and this divided by 2. We can calculate this value also using calculator. So let me try. So I have a square root of 1.76 into 10 raised to the power minus 5 into 0.02, and this whole with a minus sign, 1.76 into 10 raised to the power minus 5 and divided by 2. This divided by 2. Are you getting? So what is this value? This value also comes out to be 0.0058. You see, if I increase the decimal degree, let us say 6 degree, so I will have 0.005. So this is 5.84. So I can say this is 5.84 into 10 to the power minus 4. You see, this solution is less than exact solution. You see, exact solution is somewhere here, and this is approximate solution 5.9. So you see 5.9, and here I have 5.84, and here I have 5.8. So one value is 5.9 into 10 to the power minus 4, another is 5.84, another is 5.8. So this is all are 10 to the power minus 4. This is also 10 to the power minus 4. This is also 10 to the power minus 4. This is exact. This is approximate. And this is less exact, I can say, in the middle between exact and approximate. So this is a middle solution. Are you getting? So this is all about the solving. So if you see in this video, we discussed three methods of solving a weak ionization, weak acid equilibrium. One is approximate method, another is exact method, and then we said there is a method that is between exact and middle. And we also discussed something about error. We said how to find error and what is the condition when error is less than 5%. So we derived some ideas. So thanks for watching.